as for the evens, but I'm not quite ready yet. So, what is your first even? Let's at least make sure 6 is up. Well, P.S. At me. What?
Like it said to use graphs or tables. Do we have to draw the graph, or I just use my calculator?
I mean, for showing your work, a quick sketch illustrating the answer that you gave would be preferable. But do you necessarily have to give me tons of points on a table? No, don't do that. Is anybody else depressed? This is only section 2.2.
Why do I keep saying horizontal asymptotes are x equals? I got this from all my quiz.
X equals, it's Y equals. Y you can fly. Y you can fly. It's the horizontal ones. That was Mr. Shanks. Mr. Shanks would teach that, why you can fly. Okay, what's after number 6? A is 1, B is 1, C is 1. Dun, 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 dun. Well, how'd you get 0? Did you do the degree test? There's a tie. Absolute value of x over absolute value of x plus 1. There's a tie. Ratio of the leading coefficients. Check the sign. Positive over positive is positive. Negative over negative is positive. Oh, no. The negative changes to absolute value anyway. Either way. Degree tests. Don't worry, I already heard this morning that I didn't say degree tests enough yesterday or the day before. You were supposed to be doing degree tests. Tie. 1. Next one. Negative infinity. Okay, hold on. Does anybody else want us to slow down? We can go over questions now as we go. Okay, hold on. Anybody, do we need to go back to anything before 16? We're okay? Okay. 16 is nasty, and it could be nasty on the AP because some people just hate the from the left, from the right. It's not like a super basic given a graph. Okay, so we have the function, right? And when you plug in, don't you get negative 3 over 0? Infinity and beyond, right? But infinity and beyond, we're supposed to check plus or minus infinity with a question mark. How do we check whether or not it's positive or negative infinity? The easiest way, which I do mental math, but you don't have to, is to think of a number that's a little bit above negative 3. How about negative 2.9? Or negative 2.99? Or negative 2.99999? Infinity and beyond, if I plug in, it's negative 3 over 0. It's a vertical asymptote. But it doesn't matter. Plug in negative 3 to see what's going on. Negative 3 over 0, there's a vertical asymptote there. And you go to your negative 2.9, because that would be a little closer to 2 as opposed to a little bit farther from negative 3. And negative 2.9 is a negative over negative 2.9 plus 3. I've oriented the board like 3 times today. Anyway, a negative over a positive is a negative. Negative infinity is the right one. Dun, 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 dun. Yes. You could have. Should you have? You have to be able to do it by hand. Next one. Which one? 20. Oh. Ah! Secant. He's 1 over cosine. So cosine. I don't know how to do this one, but he's this guy where he's up here in the middle and then he's down here. I'm trying to do the dance move, but it's hard. Anyway, he's this one. That's cosine. Secant's going to bounce off. If it bounces off, it's going to have vertical asymptotes at negative pi over 2 and pi over 2. It straddles the axis. Are we good? I could pull up the cosine graph, but it's going to bounce off the cosine. So pi over 2 and negative pi over 2. Who am I going towards? From what direction? So couldn't you, yes, using the graphing calculator, but using yourselves, because you're supposed to know what secant looks like. Couldn't you say pi over 2 as you come from the right? Oh, it's going down. Dun, 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 dun. Remember, pi over 2 from above, you follow the graph that's above and then come towards. Pi over 2 from below would be positive infinity. Pi over 2 from above would be negative infinity. Secant bounces off cosine. What's next? Sides. Because it's x, and x is our left rights. And so think about it like a number line. That's why I did number line a second ago. Is it still there? Because you thought about what's x approaching, and plus is something a little bit to the right of it on the number line. Minus is something a little bit below it on the number line. So my above and below is about the quantity. As far as the graph, well, I don't know. The graph might be above or below the axis. But what I'm thinking is from the right, from the left. That's why in AB this year I've been saying from the east and from the west to remind them of what we're thinking, not north-south. That's what the graph is doing. Number next one. Sorry. What are you looking for? Vertical asymptotes? Given a function? Okay, so vertical asymptotes, looking at the denominator and factoring. That's A. Part B says describe the behavior to the left and to the right. That's probably where it got hard, right? Is that not what part B is? Okay, let's check it with. Good. We have 1 minus x all over 2x squared minus 5x minus 3. Does it say to use the graph? I need a negative and a positive, so I need a subtraction. So 2 and 3 won't work, but 6 and 1 will. 6 and 1. Good. With a negative and with a positive. 3 and negative 1/2. I think you were thinking put 2 and 3 together to get 5, and you didn't think about how this.
I just did
Oh.
x squared minus 6x and then x minus 3, like the grouping.
Oh, okay.
Did you have to?
Pull out a negative. Wait. One. Yeah. Because I don't know how else you could do it. I mean, you don't have to pull out a positive one per se. You just need to group it, though, right? And when you group it, there's an understood 1 in front. Yeah. Factor out the 2x. Sorry, I just guessed and checked. And then letter B. We're asking for not a model, but just the behavior instead. So then, and limit at negative 1/2. Oh, to the left and right of each vertical asymptote. Lo siento. It was meaning end behavior, but end behavior exists. So if you get left to the right, that DNE because it's oscillating. But they were saying, what's the behavior as you come in towards the vertical asymptotes? And so as you come from above negative 1/2, negative infinity, as you come from below positive infinity, as you come from below 3, positive infinity, as you come from above negative infinity. That's what it was asking. Which you guys could have used one-sided limits to make it a lot nicer than like the words. Ew, that's gross, but either way. They use the words, that's okay. No C? No C. What's number next one? 44? Oh, I did give you those ones. Lo siento. Why is 6 so easy? Just degree test if you realized all I'm looking at is the highest degrees and simplify. So some of you made it too hard. If you're thinking degree test, the largest degree on top was x to the 5th. The largest degree on bottom was 2x squared. So you're just taking those two, simplifying, and saying, oh, hey, 1/2. That's my end behavior model. And that's what we consider when we just look at the highest degree. We just never had a name for it. We just said, ignore everything else and focus on them. Worked. Then 38, you guys can all check. Take the highest degrees. There was an x to the 4th up top and negative x squared on the bottom. Negative x squared is what? Like if you were to graph number 38 and graph negative x squared and look towards the right and towards the left, they're going to start mimicking each other. That's the point. The same as well. But to the right, to the left, sorry, to the right, to the left. They're going to mimic each other. Yeah. Does that make sense? The names for what we do when we look at the highest degrees. Naming it as a function. Now 44? Says find a power behavior model. What it's basically saying is find a polynomial. Power function. Power. It was just a snazzy name for a polynomial, yeah. Just the same thing as far as an n behavior model. Identify any asymptotes. Well, he doesn't have any horizontal asymptotes. The degree on the top wins. He doesn't have any horizontal asymptotes. What does it take to have a horizontal asymptote? Well, you know. When do you have horizontal asymptotes? When the degree of the bottom is greater or they're tied. Good. So whenever the top wins, no. Which one? Yeah, which is why there's none. Because when the top wins, you're just going to infinity or negative infinity. Oh, it's infinity. They were asking for horizontal asymptotes, so none. Yeah. Sorry, Aryan, what? What was that one? Highest degrees. Highest degree of the top was x. Highest degree of the bottom was 2x squared. Simplify. So you have 1 over 2x. Yeah. And then what's the horizontal asymptote? Bottom wins. So 0. Or the limit to infinity of 0. Did you have 47? Y squared. Yeah, it has the same behavior. There's both a right end and a left end going to the positive infinity and negative infinity. Yeah. Why? Because sine, whether you're going to positive infinity or negative infinity, is still stuck. How is sine stuck? Between 1 and negative 1. Who's the guy who's growing? Who's the guy who's determining everything? X squared. So who wins between sine of x and x squared? X squared does. Now, what function would there, you guys wrote down the function on 48, right? What function could have been added to x squared where x squared wouldn't always win? He would sometimes, but not always. Oh. Do you guys get 45 right? Why in 45 did e to the x win one direction but not the other direction? He's an exponential function, so if you have positive powers, well, that's going to make a big difference rather than negative powers. Yeah. So in 45, one guy won one time, the other guy won the other time because you had e to the positive powers getting bigger or negative powers making the whole thing get smaller. E to the x won't always win. But sine of x, well, he always loses. Poor little guy. Who else would always lose? Cosine of x, yeah, he'll always lose. Remember, next one. 8? 70 even. Where is he? There he is. Ah! Logarithms! So mean. Do you guys remember change of base formulas? Ooh. Well, change of base formula would have worked. Because change of base formula, you can take a common log. Well, you can see it. You can take a common log and change his base to be a different type of log. This would have been the formula from pre-cal. Let me write it out because it's a little hard just for you guys to visualize, I'm sure. I don't want that. There we go. Log base b of x is equal to ln of x over ln of b. You could have changed like a log base 10 to a log base 3 or a log base 7 to a log base 10. You could have done that too, but you can take any logarithm and take a new logarithm of the argument over the new logarithm of the, that's just called the change of base formula. So I know, it's kind of mean. Pre-cal strikes again. Change the base to an ln. All of a sudden he pops up, the ln of x is reduced, and Isa. 33. Yes, anything else? Are we at the end of evens? 71 since we're right here, sure. That's okay. 71, let's start there. Are we just trying to figure out why? Is that what we're doing? Just solving the limit? Do they tell us it's 1 from the get-go? Is that not the original problem? Oh, that is the problem. Oh, okay. Basically, looking at it right now as is, I think most of us, if we saw that on like an AP question, would have guessed and been like, oh, the degrees are tied. Yay, 1, right? Like we would have just guessed that. But they're saying it is a dilemma because technically x plus 1 is not x. Do you really know what the difference is? And they're saying there is, well, basically, the dilemma is there's no property. There's no property that lets us split up the plus, right? So how can we get this guy in terms of ln of x to even be able to compare the two? And they say, well, you know what? If you can't use a property, be creative. And their way of being creative is we could use a property if only this was multiplying. Well, how can we say it's multiplying? Well, if we could factor it, but how do we factor it? Pull out something? Pull out a 1. That doesn't help. Pull out an x. Oh. Can you pull an x away from x? Sure. Can you pull an x away from 1? Sure. But you can. Technically, those are the same. Now I can say ln of x plus ln of, which is super nice. Because if I replace that up here, can't I say that as I go to infinity, this guy is just going to 0 and isn't ln of 1, 0? Who wins? This guy. And now he truly does tie. Nice. Limit is 1. Without going, they go a whole lot more. But I would have said right here, you can say that this guy, doesn't work. This guy, 1 over x. If you plug into the limit, going to 0, ln of 1 is 0. That whole thing goes to 0, and then that over that, 1. Is that cool? And you can't go to negative infinity, so we don't even worry about it if it was like horizontal. Oh, the problem was positive infinity. Sorry. It wasn't a horizontal asymptote. We're going back to 33. Is there anything earlier than 33? What? Which one? 30? No. Okay. 33? Anything before 33? 21. Number 21. Is that your original function? Ugh, that is your original function. Trying to find going to infinity and negative infinity? Okay. Just leave it. Going to infinity and negative infinity. You'd think I'd learn. Ugh, but I don't. This one's weird because there's a big old multiplication, right, guys? Okay, so with the big old multiplication, if we're taking a limit as we go to infinity, can't we technically go into the function, right? Dealing with, hold on, wait a minute. When can't we use the cool limit properties that let us kind of just take it piece by piece? Do you remember? When it equals not just constants, right? So could you take the limit as you go to infinity of 2? Yeah, that's fine. Take the limit as you go to infinity of x over x plus 1? Yeah, that's a number. Take the limit to infinity as you go to blah, 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 blah. Yes, but the direction sadly told you, I think, if I could have my butt close. Is it 21? Oh, it just says find the limit. So they went through all this work of getting like common denominators and making it one nice fraction. And with that one nice fraction, it was super obvious to go ahead and see the ratio of the leading coefficients. But couldn't you technically have also done 2 minus 1 all times 1? But how did I do that? Aren't these tied? So then x over x plus 1, that's just going to be ratio of the leading coefficients. 1, 2 minus 1. I would have just done 2 minus 1 times 1 is 1. But this way also works, just a lot more work of getting 1 as well. And whether you go to the left or whether you go to the right, a negative over a negative or a positive over a positive always gets you the same result. So you can do like common denominators and make it one nice fraction and one nice, hey, degree test. Or you could have done little baby degree tests along the way. And 2 minus 1 times 1 would have also worked. but both ways work. Number 33. Didn't you guys have to do some plane? Cosine is tangent times 1 over sine. The sines cancel. You get 1 over cosine. And then they were asking you to, what, approach the vertical asymptotes? I think. So think about, no? Was it behavior near the vertical asymptote? What's the vertical asymptote to is first is any time cosine is 0. And so cosine will be 0 every multiple of pi over 2. Every odd. Well, the reason why they're doing this, sadly, is you can't just say pi over 2n. You can't just say like every multiple, because it's not every multiple, it's every other multiple. It's 1 pi over 2, 3 pi over 2, 5 pi over 2. It's not 1 pi over 2, 2 pi over 2. It doesn't happen at pi and 2 pi also. So they had to somehow get odd numbers. The way they got odd numbers was 4k plus 1 and 4k plus 3. But couldn't they have also done 2n plus 1 and 2n minus 1? The idea is to get all odd numbers, you have to use an even, like 2n. It gets you evens. 2 times 1, 2 times 2, 2 times 3, 2 times 4. They're all evens. And take away 1 or add 1 to get to an odd number. Does that kind of make sense? So they were just saying like, hey, it's every odd multiple in snazzy language. And then it was like, okay, think about as you go towards any of the ones that come first with your secant and any of the ones that come second. So secant, any asymptote you come to, as you come to it from below the first one, you're going to be going up. From above, you're going down. But then as you go to the second one, like every other, it's messy, then you're going the opposite direction. So they were trying to put it in a way where they were simplifying or generalizing it. And so the notation was messy. It's right. It's not wrong. Just I would have used 2n minus 1 and 2n plus 1 instead, because I would have liked it more. But they used 4k plus 1 and 4k plus 3. Yeah. And that's not something that you would lose points on. That's not something, like I'm not going to necessarily ask you to give me all the asymptotes, the infinitely many, and then describe them in a general statement. Like that's not what I'm going to ask. It's just can you, when you come to a vertical asymptote, can you analyze what's going on below and above it? Does that make sense? Anything else besides 33? You're peeking at it. Obviously, we've run out of time for today. What's the next section? Continuity. How do we do with continuity? Definition of continuous, the forever card. Removable versus non-removable. Okay, a few things that might go weird with piecewise functions. A few technicalities, but otherwise it's dealing with continuity in the intermediate value theorem. Is it really anything hugely new like end behavior models or vertical asymptote behavior or coming up with infinitely many vertical asymptotes? No, it's not. Could there be a couple funny things that they're trying to like make you realize? Yes, but is it dealing with piecewise functions that we could probably use some help on anyway? Yes. So tomorrow we're going to bust out notes. This homework wasn't going to be due tomorrow anyway. It might still be due on Friday. You might still want to try and get a start on it, but we should be able to bust through notes pretty quickly. If you want, you could even tonight, if you're like, I need to do calculus, go take some notes, and then you don't have to stress as much tomorrow when we'll be writing a lot. Does that make sense? Some of you are like, continuous and intermediate value theorem. Sweet, then you can just put forever card number and have that ready. Bye, guys. I'll see you later. If anyone else has questions on, maybe we'll answer one at the beginning of class tomorrow, 1 or 2. Have them ready for me. Otherwise, we'll just move on.